Good afternoon all. Hello, welcome, thanks for coming along. My name's Neil Thompson. I'm representing the Sony Corporation today. I'm not actually an employee of the Sony gang, but they have a kind of a pool of freelancers. Perhaps a puddle might be a more accurate description, and I'm part of that puddle of freelancers. So I can say whatever I want to today, pretty much, especially as none of the Sony guys are listening, so I can hopefully tell it like it is. Although I do have a bit of a natural Sony bias. There's a chip in the back of my head that's still controlled from Japan somewhere, so if I go too far off course, they sort of send me back in the right direction. So we're going to have a bit of a chat about full frame. Full frame, it's the next big thing. I was at a similar kind of event down in London last week, and it was almost like every single one of these types of seminars was full frame and what it means to all of us and how it's going to take over the world. And it does seem to be doing that at the moment. It certainly is the next big thing. Although, strangely enough, it isn't really a video thing. If we look back into the mists of history, film was always 35 millimeters across, hence the name 35 millimeter film. It all kind of hangs together so far. But typically on that 35 millimeter film, you would arrange your images in your stills camera so that they were sort of 36 millimeters across this way and 24 millimeters across that way, maximizing the space for the images to be sort of horizontal within that string of film, as it were. And that's the way it's always been for stills cameras. And there's a whole generation of stills cameras that have had that sort of full frame sensor built into them since the days we've gone into solid state. And it all comes from its 35 millimeter celluloid origins, as it were. So what's that got to do with video? Well, not very much really, because in terms of moving pictures, we've always pulled the film through the gate in the camera in the other direction, as it were. So we would typically run our film through our gate and use a good old mechanical shutter to pull it down into the next frame and expose it. But each frame would be arranged across the piece of celluloid rather than along the piece of celluloid. So you would, in a typical moving picture camera, you wouldn't be able to get quite such a big frame. So when we look at something like Super 35mm film, which would typically use up this sort of shape on the actual 35mm celluloid film, it would typically have 3 perforations per frame and would be a significantly smaller size than the equivalent stills frame. So there's always been this distant difference between stills photography with its large frame that goes horizontally across the film and moving pictures where the frames are arranged vertically and therefore have to be a little bit smaller in order to fit in. So in the world of stills, we're used to this large format sensor, and 34mm by 36mm by 24mm is a very familiar number in stills photography. But there are many other different sensor sizes, as is the same in the world of video. In the world of video, you also have different sensor sizes as well. But in the world of movies, typically you would only really have Super 35mm and then straight up to 65mm and nothing in between. So using what we would call full frame as a standard for video is a bit strange. It isn't really a standard for video, but it has become so. And when we say full frame now, I think everybody pretty well knows that we mean a 36mm by 24mm frame that's kind of exactly the same size as you would find in any of the full frame stills cameras from the major manufacturers, whether it be Canon or Nikon or Sony or whoever. So that is what we mean by full frame. And compared to our video cameras, which in the olden days were 2/3 inch, or in latter days were Super 35mm, it's a significant increase in physical size. So it's a big increase in the actual real estate that we're taking up in the world of our sensors. So what is moving to a large sensor going to do for us? Well, to read the blurb in most of the industry press, you'd think it's going to cure all known diseases and establish world peace and understanding forever, really, but it may not be quite as powerful as that. But it certainly offers us some interesting new tools in our toolkit, as it were. First of all, it gives us more surface area. So what are we going to do with that physical surface area on our sensor? Well, we've got kind of two choices. We can squeeze more pixels in, or we could keep the number of pixels about the same, but make them bigger. And either of those two options will give us different kinds of benefits. So the choice that Sony have made with their full-frame cameras tends to be more the first of these, where they've increased the surface area, kept the pixel sizes about the same, but stuck some extra ones on. And hence you see numbers like 6K floating around rather than 4K, giving us the clue that the image sensor has gone up from 4,000 photo sites across to about 6,000 photo sites across. But rather cunningly, they've kept the actual size of those pixels or photo sites exactly the same as it was, sort of thing, just stuck some more of them on. And it seems to have worked out quite well, but we'll come back to that in a little while. So if you go to a big frame on your sensor, you've also got changes in the way your lens works. And typically with a large sensor, you'll have a better wide-angle performance, assuming you can find a lens to cover the whole sensor. But the downside to that, of course, is that the long end of the range, the tight end performance of the lens would typically be less. Here's a word I have trouble with, bokeh. I can't pronounce it. It wasn't until fairly recently, I didn't even know what it meant, to be honest. Coming from an engineering background, I was interested in, is it in focus or out of focus? And that was it. But apparently there's more to it than that. And I may be a bit of an old stick in the mud, but apparently the bokeh, the way the image defocus happens when you go to a larger sensor, gives you a different look to your image. And it does look different. Now, whether that's a good different or a bad different, I wouldn't be prepared to say. But that's your decision. That's a creative choice or something like that, I believe. So that's something that's different about moving to a larger sensor. The way the image goes out of focus looks a little bit different. Not a massive amount, but this is one of those things you could have a look at on our FX9 camera, which is just over there. I was going to bring it here, but to be honest, it's not exactly a long way to walk. So when we've done the presentation bit, you'll all be very welcome to go walk over it to have a bit of a play with it. And you can try the large format mode and the Super 35 mode and see if you can spot the difference in the bokeh. And finally in the list here, you get a shallower depth of field. Well, that's kind of true. And in its practical effect, it is true, but actually, physically changing the size of the image sensor doesn't actually change the depth of field that you get. And I'll illustrate that to you a little bit later on. But some of the bits that you need to be aware of is that, of course, if you move to a big sensor, you need a lens that will physically cover a larger area. And in order to project that large area of an image, it needs physically to be a big piece of glass. And this is something that sometimes people forget. When you keep moving to larger formats, the actual physics of that process mean that you actually physically, of course, have to increase the size of the glass, which means more size and more weight and more polishing of very expensive glass. I'll give you for example. I don't know if anyone can remember there was the Brazil World Cup 5 years ago or something like that, was it? Getting on for that. And Sony put their hands up and said, oh, we'll do it in 4K, everybody. We'll do it. Which was kind of a rash thing to do because they had a 4K camera called the F55, and they've still got that same camera, still going, still doing well as the F55. But it had a Super 35mm sensor, which by video standards was a big piece of image sensor. And then they suddenly realized, oh, blimey, we haven't got any glass that will actually cover this sensor and give us the sort of 86:1 zooms that we're used to on a football match kind of scenario. football matches, believe it or not, astonished though you may be to find this, are somewhat different to a film set. You typically need a big old zoom lens, even on a 2/3 inch camera. So when you multiply that up to a Super 35 camera, your 86:1 zoom, as it would have been in the old days, would be about the size of a Mercedes Sprinter van, and somewhat more expensive. So you just need to bear in mind this, that when we go full frame, there will be a cost implication in terms of lens technology. There's nothing for free in this life, I'm afraid. And typically, those lenses will have less reach to them, if you like. A lot of natural history wildlife photographers have been just eaten since we started introducing large format sensors, because they have to get so close to the animals now in order to get the shot that many thousands of them have been just eaten by wild animals. That may not actually be true, but the general principle is that for long lens work, a large format sensor may not be the ideal solution. And typically, of course, in natural history, you do want long lenses in order to get close to the action from a long way away. So those are some of the things to bear in mind when we talk about moving to this full frame world. But it also gives us some other choices as well. And it allows us to do other things. Having a big surface area of real estate that you can reconfigure into different formats is quite a powerful tool now. So anamorphic becomes a possibility with cameras like the Venice camera. The Venice camera isn't actually on the Sony stand. We couldn't afford one. It's actually on the visual impact stand just over at the back there, so not too far to walk. So you've got anamorphic solutions, which I'll talk through in a minute. And typically those will enable you to produce in CinemaScope, and you can produce in CinemaScope with a circular lens as well as an anamorphic lens by using a different configuration of the full frame image sensor. You can shoot in 16:9, good old Super 35. Although a friend of mine who runs a production company doing a lot of stuff for the World Wide Web says, 16:9, 17:9, we don't shoot in that anymore. And apparently the world has moved on. Nobody's told me yet, but we're now moving into a world where aspect ratios can be pretty much anything you like now, and we're talking about 5:4 for all this newfangled social media stuff, and people like Netflix are saying, oh, we really like 2:1. Okay, well that's fine, but the camera kind of doesn't actually have a 2:1 straight out the box. But there are different ways of getting to all these different aspect ratios that people would prefer to use, if you've got a nice big area of sensor that you can crop into different configurations. So you've got lots of different options from the point of view of using the area available. So just coming back to the decision about how big should an image sensor be. There are limitations. You can't just go on embiggening, which is a new word that I have just made up there. There are laws of physics to take into account. And lens design, the display that you're going to be using, the capabilities of your manufacturing process, all come into play here. And it wasn't so long ago that going to these sort of image sizes in the days of CCD technology. Anyone remember CCDs? Oh yes, still some of us left. That's great to hear. But there was no way of making CCDs, manufacturing point of view, big enough to do all this Super 35 and full frame business. Just wasn't going to happen. So manufacturing techniques have moved on to allow us to do that. But even so, there's a limit to how far we want to go with that. And I would say, until next year, that full frame is about as far as we want to go, really. If anyone wants to do 65mm, then good luck with that. But I think really we should stop at full frame. And there are also things like the physics to take into account. As I said before, in practical terms, increasing your sensor size reduces your depth of field. And we're now getting to the point where if your subject starts rocking about and moving in the way I do when I'm sort of speaking or whatever, as I'm sure is irritating you intensely up at the back there, if your subject keeps rocking about like that, your whole face goes in and out of focus because the depth of field becomes so shallow that you only need to move a few centimeters forward and your nose goes all blurry, which could be a good thing. I don't know. Maybe that's a positive, a blurry nose. So taking into account all these factors, then full frame seems a bit of a sensible upper limit on the size of your image sensor for normal production. But just going back a step and looking at the cameras that Sony have got in the Super 35 world, some of them will be maybe very familiar to you. The FS7 is hugely popular camera. The FS5, the F5, the F55, they all use fundamentally the same image sensor. It's tweaked a bit for the different cameras, but it all comes from the same background. So they're all Super 35mm cameras. But we've now moved into the world of full frame. But of course, we've kind of already been there for a little while because consumer land has come from the world of digital stills, obviously, and has been full frame for some time now, some years. If you go right back, I guess we need to give credit to Canon and the 5D Mark II, which was the first camera, I would imagine, to push us in that direction. But then we have the Alpha series, the A7, the A9, which have been hugely successful. And to be honest, if you pull the image sensor out of the A9 camera and have a close look at it, it's not that different to what goes into these new cameras, the Venice and the FX9. It is different, but in terms of its physical size, 36mm by 28mm, in terms of pixel spotting, 6,000 by 4,000. In terms of aspect ratio, 3:2, it all looks very familiar. So this same technology has come across from stills right into the top end with the Venice camera and into the mainstream with the new FX9 camera at a stand near you for your convenience. So these are the three sort of groups of cameras from Sony. And I want to start by using the Venice camera to illustrate some of what I was talking about before. So this has got the 36x24 full frame, originally designed for Venice, all new and shiny. And to be honest, that's one thing that Sony are pretty good at, actually, making sensors. Their image sensing division is going like a train on roller skates, whatever that is. That would be pretty dangerous, actually. No, it wouldn't go like that. But the image sensing division is doing really well. And they make all sorts of sensors. Annoyingly, they put them in all sorts of competing cameras from other manufacturers. So as part of my job as sort of representing the Sony gang, I have to tell people how rubbish the Panasonic GH5 is, when of course it isn't. It's really good. And part of the reason it's so good is, annoyingly, it's got a Sony image sensor at the front end. But anyway, you know, that just illustrating that the sensor technology is a strength of these cameras. And all new CMOS architecture, super fast readout, so it's effectively a global shutter, all the usual bits and pieces. But I don't really want to get into that too much at the moment. What I want to talk about is what I was talking about before, where we look at that 3:2 sensor and we say to ourselves, so who's shooting in 3:2? Anybody? Anyone? Almost kind of photography, yeah, and that's it, really. So that's not really the point. As I was saying before, it gives you a lot of options. Now, the Sony Corporation is never shy of giving you choice. However, sometimes choice, my friends, is the enemy of freedom. And you end up with a diagram like this that says you can do this, that, And these are some of the different aspect ratios, cutouts, crop modes that you can work with on the Venice camera. And Sony put these diagrams on the brochure and say, well, that's perfectly clear. Well, it isn't. So I've tried to break it down into sort of slightly more manageable chunks. So we start with this big full frame area, coming back to our 36x24. And that's our big chunk of real estate. And a lot of the time, we're not going to be using all of it. In fact, most of the time. In fact, if you want to use all of this area on the Venice camera, you have to buy an extra license from the Sony Corporation, and that costs you another arm and a leg. But they don't tell you that at the time until they say, oh, by the way, did we mention you need a license for the full frame 3:2 sort of option. But once you've installed that license, you can use the full frame, and it's a very powerful sensor indeed. But most of the time, you're not going to be using it like that. A lot of people who've bought the Venice camera just use them almost like an F55 or an FS7. You basically chop out a Super 35 size chunk out of that full frame sensor, which by a cunning plan happens to have 4096 by 2160 photo sites on it, which works pretty well for 4K and is exactly the same kind of operational mode as you would have in an FS7 or an F55 or indeed an FS5. So you kind of just have F55 mode on it, clunk, and it works in Super 35, and you can put Super 35 lenses on the front of it. And you don't need to go to the expense of buying the full frame lenses. You can just put your existing Super 35 kit on the front. Indeed, the Venice camera has a removable PL mount on the front of the camera. You take that off, and underneath is kind of exactly the same E mount as you would find on an FS7 Mark II. And then you can put on all sorts of, I don't know, Fujinon MK series, for instance, which is a really nice Super 35mm zoom and lenses like that. So you don't need to plunge straight into the full frame world. You can take it step by step and start maybe in Super 35 mode. If you're getting ambitious, you can go into this mode, 4x3, which sounds a bit retro going back to 4x3, but a lot of people are using 4x3 as a way into anamorphic world. And I can sense that we have one or two anamorphic fans in the room. And anamorphic is, well, it keeps going in phases. It's suddenly hugely popular and trendy, and then it dies back a bit, and then it comes back. Anyone done any anamorphic stuff at all? Yeah? And people either love it or hate it, and it certainly gives you a creative look. Again, from a boring old engineering point of view, I'm not desperately keen on optical distortions and flares and things like that, but if that's the look you're after, then anamorphic is the way for you. So you can use a 4x3 and a 2:1 anamorphic lens, which effectively makes it into 8x3, which is just a little bit bigger than CinemaScope. You end up having to crop a little bit off the edges. And that's the way Arri have traditionally done anamorphic on their cameras. And Sony can do the same thing. But, oh yes, my friends, they can do even better than that. 6x5 mode on the Venice. 6x5, if you multiply 6 by 2 with your squeezed lens, you end up with 12x5. And a 12x5 aspect ratio, if you divide 12 by 5, is exactly 2.4 to 1, which is near as damn it exactly right for CinemaScope. So you don't need to bother chopping bits off the edges and putting frame markers in. It's all just ready to go straight out of the tin and uses the maximum amount of resolution possible as well. So that's two modes. And sorry, I ought to mention, in order to get access to these modes, you need to buy another license. It's called the Anamorphic license. Oh, yes. So that's a pretty powerful tool, though, again, and gives you two different ways of producing anamorphic images. If you don't want to do anamorphic, you can, instead of doing a 16:9 and a 17:9 at 4K, you can do a 16:9 and a 17:9 using the full 6K resolution. And you can either record at 6K into the RAW recorder on the Venice, or you can record onto good old S/S cards at the 4K resolution where it's downsampled. So that gives, and actually these modes are very similar to what you have and will have in the FX9 camera. The FX9 doesn't offer you the anamorphic modes, so it's not quite as flexible in terms of the anamorphic performance. You can also just chop a CinemaScope frame straight out of the image and use circular lenses on the front of the camera. So you can put a circular lens that covers the full frame, some Zeiss spangly, super accurate sort of perfect round lens with no optical distortions, and a 2.39 to 1 straight out of the box there without any anamorphic business going on. Your choice is yours. So as you can see, there's a whole raft of different ways in which you can use your full frame resource, as it were. So all this anamorphic business, 2.39 to 1, 16:9, 2 times 4:3, all that business, it's a little bit complicated and get your head round sort of thing. So this diagram kind of illustrates what we're doing here. With a 4:3 sensor, we put a 2 times anamorphic on it, and we get a 2.67 to 1, which is a little bit wider than you need for CinemaScope. If we move into the future, it's likely that people will want to use the whole 3x2 imager for doing an anamorphic sort of production. And if you were to find a times 1.6 anamorphic lens, put it on the full frame 3x2 image sensor, you would end up with 2.4 to 1. Trouble is, the only people who make a 1.6 times are Panavision. And that's a kind of a highly specialized lens and somewhat expensive. But you get the general principle if you can find 1.6 times anamorphics. Although some people would argue that that isn't sufficiently anamorphic to make it look truly anamorphic. It's a bit of a halfway house. So you could also use a times 1.8 from Cook, which are already available. And 1.8 times 3 divided by 2 is 2.7 to 1. So it's a little bit wider than you need. So there's a bit of fiddling about and a bit of messing about with de-squeezing images for your viewfinder, but you've got a whole range of possibilities with the anamorphic side of things. Now, putting more photo sites on your sensor because you've got a bigger sensor is great. And these sensors are all 6K across, 6,000 photo sites across. The slight disadvantage is that you need to read them all out. And in order to do that, you will use a bit more power, and it takes longer to read all those pixels out. And because of that, typically, the bigger your frame size in terms of its pixel resolution, the fewer frames per second your camera will manage to generate. So there's this trade-off. So you'll find that most of these cameras in the full 3x2 mode or in 6K mode will only top out at something like 30 frames a second. And if you want to do high-speed photography, basically something has to give. And you end up typically going down, cutting down to Super 35, or maybe cutting down to Super 35 and then downsampling to 2K rather than 4K. And there's a straightforward trade-off. The less sampling you do, the faster you can go. And I suppose that still leaves us room for improvement in future generations of cameras. And one thing to just be aware of, clocking out more data soaks up a bit more power. So the FX9 camera, for instance, as lovely as it is, and it is indeed lovely, it will go through your batteries at a faster rate than FX7s will do because it's drawing more power because it's doing more work and clocking out more pixels. And that brings us on to another. It's kind of an idiosyncrasy of the FX9 camera that we brought along today. The only one in Europe, by the way. Sensor readout and recording resolution are two slightly different things. So on the front of the FX9 is a camera that is 6K photo sites across. And yet all its recording options, which does make things simpler actually, are exactly the same as the FS7. So it's still 4K or 3.8K, XAVCI, XAVCL, good old-fashioned MPEG. All that familiar stuff is still there in the FX9. And yet, the image sensor itself is sampling at a higher sort of rate. And you notice I said photo sites rather than pixels because the manufacturers are a bit keen on saying 4K pixels when of course it's only a pixel when it generates independent red, green and blue information. And you can't really do that from a Bayer pattern sensor by just counting the photo sites across and calling them pixels. But it does mean that you effectively need more photo sites across 6K, for instance, in order to generate a 4K complete image. So although it samples at 6K and only records at 4K, that sounds like a mismatch. It sounds like somebody's made a mistake here. But actually, it works really well. In general, with a Bayer pattern filter, you can reckon on a 0.7 times factor to take into account the fact that it's not got independent red, green and blue sensors. So if you've got an FS7, for instance, with 4,000 pixels across, 4,000 times 0.7 is 2,800. You can, to be honest, you can probably reckon that the camera is actually a 2.8K camera rather than a 4K camera. But nobody ever mentions that. We don't talk about that. We all just put big gold stickers on the side that say 4K. And as long as all the manufacturers do the same thing, then we're okay. And nobody's really getting burned here. But in the end, it's better to sample the image at a higher sampling frequency than the recording sampling frequency. So 6K to sample the image on a Bayer pattern sensor works really well to give you a good 4K to record your image. I mentioned before that if you change the sampling, the image sensor size, you can go up to a different speed. And people ask me sort of, what's the highest frame rate that a Venice will do? And it's just, it depends. It's massively complicated. And if anyone needs to know, I've produced a nice little chart here that is still massively complicated, but it actually tells you the answer. At any given sampling size and aspect ratio, how fast will you be able to go? So in some circumstances, with a RAW recorder and an extra license, you can get up to 110 frames in 17:9 at 4K. But it varies, so it's a really difficult question. Not quite so difficult with the FX9, but still quite complicated. So here's the equivalent numbers for the FX9. And as you can see, in full frame 6K mode, you'd typically be at 30 frames a second maximum. There's a big number here, 120 frames, but that's only because we've downsampled to 2K. So it's a trade-off, as I mentioned before. And if anyone needs to go through the frame rates that it's capable of, just give me a shout after the show and I can talk you through them. And quite a few of them are sort of future developments as well. I guess many of you are familiar with the F5, FS7 sort of series of cameras. Sony have been quite good, really, at introducing new software versions that give you extra features. I think this will continue that tradition, and there are various things planned for the future. And they do tend to deliver on time. They will publish a timetable and say, look, by this date, we'll give you this, that, and the other. And usually they chuck a few extra little features in for good luck as well. So there's lots of different recording modes there. And the FX9 is very similar to the Venice sensor, apart from a few things. One thing that gives it away is there are photodiodes built into the sensor that are there for working with the autofocus system. And the autofocus is a key bit of technology in the FX9. It has both phase detection, where it just looks for a sharp edge, and it has, it has contrast detection, where it looks for a sharp edge, and it has phase detection, where it uses inbuilt photo sites in the sensor to work out which direction to start moving the focus in order to get to the correct spot. So it doesn't do what I do, which is frantically wobble the focus ring around and think, it's that way, and then realize, no, it's the other way. It doesn't have to do that. Because of the phase detection autofocus sites, it knows which direction to set off in. So there's no wobbling about and any of that nonsense. It just works. And it's also linked to the face detection, face recognition systems built into the camera. And I think people have got to kind of review autofocus as what was once viewed as a sort of, amateur time. No, we don't do that here. It's now just another tool in the box, and in certain circumstances, it's a very valuable tool indeed. But enough about autofocus, that's not really why we're here. The sensor's the same physical shape, 6K, but we don't use the full height of it, so it's not 4K. When it's in full frame mode, it's that sort of sensor size, 40 millimeters across. And that's its 6K 17:9, and it's 5.7K 16:9 modes. And then, like in any of these other cameras, it has a center crop out mode, if you like. But the center crop, rather than being just HD, is actually a Super 35 size 16:9 sort of chunk. Just think of it as FS7 mode. So the FX9, if you use it in full frame mode, you have to have the full frame lenses to cover the full frame, logically. But if you haven't got full frame lenses, it's the normal E-mount, same as the FS7. Switch it into FS7 mode and just continue as you were, treating it as though it was an FS7. And it's very simple and straightforward to do that. And it still gives you all the extra functions of the camera, like the autofocus and the dual base ISO rating and the extra dynamic range and the really clean pictures and all that stuff. But you just don't use the full frame. So you don't need to use full frame just because it's capable of it. You can just carry on working as you were in Super 35 mode. And there will be a 17:9 variant of that on the roadmap very shortly. And there's only one other flavour in the FX9. It's not quite as confusing as the Venice camera, and that's a 5K mode, which is a bit odd. Who uses 5K? What's that? Why would you do that? And the answer is it's the biggest frame they could clock out and still get to 60 frames a second. They wanted to be able to make it to 60p and put that on the as a frame rate. As I said before, the full frame will only get you up to 30 frames a second maximum. But if you knock it down a little bit, down to 5K, you can get up to 60 frames a second. And that's the thinking behind that frame size there. So lenses, I'll skip past the Venice camera, but the Venice camera has a PL mount on the front and an E mount underneath, and the E mount is exactly the same as the FS7 Mark II, basically. There's a lot available of lenses from all sorts of different manufacturers. I just want to mention the kit lens that is available for use with the FX9. And this is a weird thing, this is a kind of a vintage lens come back to haunt us sort of thing. If anyone remembers the FS7 Mark I kit lens, it was this lens. And for the FS7 Mark I, it was a bit of an odd one because it's a full frame zoom. And it was paired with the Super 35mm camera, which was kind of a little bit of a waste, really. And now, bizarrely, it's kind of come back into its own, and it's the rebirth of the SEL P28135G, as it's so catchily named. So this 28-135 zoom, you can buy with the camera as a kit lens. It's a bit idiosyncratic. It's a fly-by-wire zoom, for instance. So you crash the zoom ring, and then 5 minutes later, the zoom goes, whoa, we're off, and off it goes. And it goes very smoothly and nicely, but it's a bit of a lag on it. So it's one of those quirky we call it. You might just call it weird. I call it quirky. And try before you buy. But nothing comes close to it in terms of offering value for money in terms of the zoom range on a full frame camera, really. It's under £2,000, significantly under that. And you might find an FS7 Mark I owner who's got one gathering dust in the garage, doesn't realise what it's worth and could get it for 500 quid, probably, maybe. So, yeah, this lens has kind of come back into its own, strangely enough. But of course, there's any number of lenses that can go with the camera. But it is a challenge to find a full frame lens that's going to do what you used to be able to do with your Canon J20 or your Fujinon HJ22 or whatever. Those kind of B4 mount lenses that you could work with all day long, every day, just simply don't exist. And we're all looking for the one lens that's going to do everything. And it don't exist. It ain't there yet. So that's that lens. Oh, Sony are launching a new Cine-style E-mount lens, motorized, and 16-35, it's an f2.8 T3.1 G series lens, which is really nice, but the price tag's a bit, try not to look at that bit there. Try not to notice that bit. Lens coverage, lens tables. I won't go on too long, actually, but I just want to mention sensitivity on these cameras. If you there's a generally accepted theorem that putting bigger pixels on a camera it makes it more sensitive and gathers light better and gives you better dynamic range. That's kind of true, but maybe not for the reason that you'd think. If you imagine, you would think putting bigger pixels on, going from HD to 4K, you'd be able to gather more light. But if you think of all the photons coming in the front of the camera and landing on the image sensor, you're capturing all of them here and turning them into electricity. But actually, on this sensor, you're still capturing all of them and turning them into electricity. It's just a slightly different arrangement sort of thing. What does make a difference is the plumbing. So the wires and the pipes that carry all your electrical charge out of the sensor are kind of a fixed size, and they don't shrink down terribly easily and end up taking up more space on the surface of the camera. So you can shrink the pixels down, but the pipes stay the same size and clutter the thing up a bit, really, which is what reduces your sensitivity. So you need to find a ways, including sort of on-chip lenses, that focus the incoming light just onto the active pixel area, which is quite small on our Ultra HD sensor here. So, however, the FX9 just uses the exact same pixel size as you had on the previous generations of cameras, but just puts a few more of them on there. If anyone wants to talk to me about dual ISO, I'll chat you through that. Just want to finish very briefly with a bit about depth of field, because that's one of the big things about moving to a full frame sensor. You get the shallow depth of field thing. And that's true in the practical sense. I won't guide you through that weird diagram there, but if anyone's interested, you can come and chat to me later. But let me give you an example. So imagine you have our full frame sensor and you're using all of it on our FX9 or Venice or whatever camera it is. And then we switch to, well, in this case, it's micro 4/3 mode because it's half the size, but you switch to a crop mode. But switching to a smaller sensor, does that give you an increased depth of field? Well, the answer is no, it can't possibly do, because you're just using a different bit of the same image. And if it's the same image, then the depth of field is the same as it ever was. What you do need to do, though, when you crop down to this image, you've still got the shallow depth of field going on here, just not as much of the frame. So what you have to do is you then have to put a wide-angle lens on the front, or a wider angle lens on the front, to get the same angle of view back. And when you do that, it's changing the focal length of the lens that actually changes your depth of field and makes it into a deep depth of field image. So that changes back, and what you can do then, of course, is open up the iris. And if you've chopped down to a Super 35mm format, if you open the iris by 1 2/3 stops, you'll get back to the same depth of field as you started from. The trouble is, more often than not, you won't be able to open up by 1 2/3 stops because you'll be working wide open anyway. So it's not really a practical solution. So a full frame sensor definitely does give you a more shallow depth of field, but perhaps not quite as shallow as you might have thought. Or should I say, perhaps not quite for the same reason as you might have thought. It's not so much the image sensor size, it's what you have to do when you change the image sensor size to maintain the field of view. So I grabbed a couple of stills from the back garden at the weekend. The sun kept going in and out, and I'm not a great cameraman. I should have had a professional here to do this for me, but you know. So this is 2 different shots here, and you've got to try and guess which is which. So that's A, and that's B. And that's A, and that's B. So which is the full frame one? It's not, obviously it's not easy from where you guys are sitting. I'm stood right in front of it here and it's still not absolutely clear. But I'll tell you anyway. A is the full frame one. You can tell because of the bokeh here, the amount of blur on this plant at the front of the frame. And B is the exact same shot, but shot in Super 35mm mode. So what I've done is I've just cropped the sensor from full frame on A down to Super 35 on B, and then opened the zoom up a bit, zoomed out to correct to the exact same frame size. And can you tell the difference? It's not desperately easy. I've got the same again here, so I've got A and B, and A and B, and I should have changed it around a bit because the order's the same. So A is the full frame, B is the Super 35. Actually, one of the things that you can see on this, even on my sort of fairly simple frame grab from a recording in the back garden, is the actual resolution is significantly higher on the full frame than it is on the Super 35. You can actually see that quite clearly. So when I was saying about the 6K sampling coming down to 4K, it really works. It makes a difference. And it's kind of visible and there to be seen. And on that bombshell, ladies and gentlemen, I shall leave you in the world of full frame. And if anyone wants to come and chat, I'll be over by the Sony stand with a camera to illustrate perfectly all these fundamentals that we were going through. Thanks a lot, folks.